Um, so the big thing right here is that this number now has this problem has a number in front, which really shouldn't be an issue. It's just that we don't see them that often, and it looks like you guys are not sure how to like do that one step. And if you mess up that one step, messes up everything else. So first things first, let's get the 6 over. So that doesn't change. So we have 3x squared. Oh my gosh, my head is not listening to my head. 3x squared minus 2x equals 6. Okay, here's the step where people are not doing right. When you take this 3 out, you have to take it out of both of them, even if it's not really the GCF. So that 3 has to come out to the front, and then the parentheses is going to say x squared minus 2/3 x, and then equals 6. So that part right there with the 2/3, that's the part that people are missing. Now the reason why you have to do this is because in order to complete the square, this has to be a 1. So even if it's not a true GCF, we're going to take it out anyways. And everything else is exactly the same. So we would now do the cycle. So this is x. We'll still have that silly 3 in the front. The cycle is based off of the middle number, so we have to divide it by 2. I think when you divide it by 2, what's 2/3 divided by 2? Divided by 2. Is it 1/3? Yeah, so it ends up giving you negative 1/3 right here. And then you have to square it. So when you square negative 1/3, it gives you plus 1/9. And then you have to multiply it with the number that was in the front. So 1/9 times 3 is 1/3. So we have to add 1/3 to this. 1/3. That way we can balance it out. So 6 plus 1/3, I think that ends up being 19/3. And that's to complete the square step. So now we need to take it to the next level, and we actually have to solve it. So to solve it, we have to, usually we would square root, because we don't normally have a number in the front besides 1. But now it's a 3, so we have to divide by 3, and then we have to divide this by 3. So I think when you do 19 divided by 19 over 3 divided by 3, it ends up giving you 19 over 9. So over here we have x minus 1/3, and it's squared. So now we can do the square root step, since there's no number in front. So when you square root this, this is plus or minus square root of 19 over 3. The square root of 9 is just 3. And then we have x minus 1/3 out of the parentheses. And then we just have to add the 1/3 to the other side. So our final answer is going to say x equals 1/3 plus or minus square root of 19 over 3. So if you notice this type of answer, it's got the radical in it now. So we can't split it up and solve the 2 problems. So we just leave it like that. What that tells us is that problem could not have been factored. If we were to try to do it like a complex ABC, it's not going to work. So that's what it means when you get a square root in your answer. Another thing, you should also hopefully notice this looks like the quadratic formula. Negative b plus or minus square root b squared over 2, what was it? 4, b squared minus 4ac all over 2a. That's what it would turn to if we actually did the quadratic formula. That's all I had back. What's up? Well, what I did was, I didn't take away the negative. I didn't show the step because I ran out of room right here. You have to plus it to get it to the other side, so you're solving for x. So if you notice, the equal sign is right here now, and now the 1/3 is not with the x in it. So that's why it changed on it. Okay, so I have some relatively, I think, easy stuff for you to do today. We're going to be solving equations, except these equations, they have radicals in them. Now, I was thinking about like the best way to explain how to do this, and this is what I came up with, bless you. There is a certain order that you have to do the problem in. And so the first thing we're going to do to all of these problems is we're going to get rid of this b first, if it's there. If it's there, we need to either add it or subtract it to get rid of it. After that, the next thing we're going to get rid of is the a. If there is a number in front of the square root, we have to divide it to get rid of it. And then finally, we're going to get rid of the radical. The radical is usually the last thing we get rid of, and then we can solve for x after we're done with that part. Now, you will be expected to always check your answer. I know that in the past, it's usually just an option like, hey, if you want to know if it's right, plug it in and see if it works. Anytime you're working with square roots, you have to do it because you need to check if there are extraneous solutions. We've talked about that in the past. An extraneous solution is an answer that you get by doing all of your math, but then you go back and plug it in and it doesn't work. So it won't give you an equal statement. So the big thing about this is we are trying to isolate, and that's what it's saying inside that blue box up above. We're just trying to isolate the radical. That means we don't want anything outside of the radical. So in order, we would have to add 6 first. So we add 6 to both sides. And I think that gives you 24 equals 4 radical y. And then we have to get rid of the 4 because we don't want anything outside of the radical. So we would have to divide by 4. So we have radical y equals 24 divided by 4 is 6. And then to get the y out of the radical, we just raise it to the second power and then do that to the other side. So we get y equals 36. So if I was to do a quick check, I can take 36 and plug it back into the problem. Radical 36 is 6. 6 times 4 is 24. 24 minus 6 is 18, so it works. So that's our final answer. Okay, next problem. Remember, this is all about getting the radical by itself. We don't want anything outside the radical. So I have to get rid of the 2 first. Let's see. So I subtract 2 to both sides, and I have 3 equals radical 3x. Now, in the past, I've seen students try to divide by 3 here, but you can't do that because the 3 is inside the radical. So to get it out of the radical, now we have to square the entire thing. So we square that, and that gives us 9 on that side. The radical and the square cancel each other, so now we just have a regular 3x, and then we can just divide it by 3. So x equals 3 is the possible solution. So a quick check. We go and plug it in. 3 times 3 is 9. Square root of 9 is 3. And then plus 2 is 5. So it works. That's our final answer. Now notice in this next question, the radical is longer. We can't mess with the stuff outside inside until we square it to free it. So we got to get rid of all the numbers that are outside first. So in order, we have to start off by getting rid of the plus 5. So I would subtract 5 from both sides. That gives me 15. Then I have the big long radical, x minus 7 in there, and then I have a 3 in the front. So then I get rid of the number in front, so I divide by 3. So that's 5. Then I have a big radical, x minus 7. Once all the numbers are gone from the outside, then we can square it to get all the stuff from the inside out. So we're going to square this. We have to square this. Whatever you do to one side, do to the other. So this is now x minus 7 equals 25. And then you just add 7 to both sides. So x equals 32. So if we go back and plug it in, it's 32 take away 7, that's 25. The square root of 25 is 5. Times 3 is 15. Plus 5 is 20. So it works. So I think the big thing right here, make sure you check your answers. You should always check your answers because in these problems with radicals, it is going to be possible to get an extraneous solution. So if we, oh, that was the other one I had ready. Here's a couple more. I'm gonna pause to let you try it. So try these next two. So this is basic solving equations. Just the big thing now is you have to be aware of this radical right here. We never mess with the radical first. We get rid of all of the numbers on the outside of the radical. So we subtract 4. So that gives me 4 equals radical 2x. To get the stuff out of the radical, once you've isolated the radical, you just square it. And so 2x comes out. Square the other side. Whatever you do one side, you do the other. And then you just divide both sides by 2. So x equals 8. Go back and do a quick check. 2 times 8 is 16. Square root of 16 is 4. 4 plus 4 is 8. So that is the answer. Next one, you have to subtract the 8 first. So that gives you 4. You have the 3 in front of the radical x. So you have to get rid of the 3 first. So you divide by 3. So that gives you 4 over 3. And then you're left with the radical x. Now you have to get the x out of the radical, so you square it. So that just gives you 16 over 9 equals x. Quick check. Square root of 16 over 9 is 4 over 3. 4 over 3 times 3 is 4. Plus 8 is 12. So that works. Okay. So now, take a look at these two problems. These problems are separate from the other ones because they look different. What do these have that are different from the problems that we just did? Like, how are they different? Yeah, so you have an equal sign, and then there's a second letter there. In all the other problems we did, there was only one letter, and it was inside the radical. So we're not really going to change how we do this, but the way that we solve it is going to have to change just a little bit. So if you notice, there isn't anything I can do right there in that question. So I want to get this radical, I want to get it out. Like, I don't want the radical in there. So to get rid of the radical, we're going to put this in parentheses and we're going to square it. But to keep it equal, we're going to have to square the other side also. So we now have a problem that says p squared equals 2 minus p. Now I graded, I was looking at the tests over the weekend, test 5 and then test 4 corrections, and there's people that think you can square root just the p squared and that's it. That's not fair. You can't do that. There's people that think you can divide by p. You can't do that either. When you have different p's in your problem, you have to get the entire problem equal to 0. So I want to keep the p squared positive, so I'm going to subtract the 2 and I'm going to add the p. I want it on the other side. So I'm going to add p minus the 2. So that cancels and that cancels. So we have equals. Then we have p squared plus p minus 2. Now you may or may not recognize this, but this problem needs to be solved by factoring because that's a simple ABC. A simple ABC is where you multiply the first times the last. That gives you -2. You make the list. You're trying to make a plus 1. So you would have to do -1 plus 2. So this would factor into p minus 1 and p plus 2 equals 0. So then you set each part equal to 0. So you end up with p equals 1 and p equals -2 for your two possible solutions. Now we have to also, don't forget about checking the solutions. So if I have p equals radical 2 minus p, we need to check both of these. So if I put a 1 here and a 1 here, are those really equal? What's 2 take away 1? What's the square root of 1? Still 1, so that works. So then we have to go back and we have to check the other one. If I put a -2 here and a -2 here, What's 2 minus negative 2? That's a positive 4. What's the square root of 4? So that would give us a 2, but then on this side we get a negative 2. So that's an example of a problem where it doesn't work. So the negative answer is extraneous. So these are our answers right here. And I'm going to be honest with you guys. Most of the time it's the negative that's extraneous. So if you get a negative answer, double check just to be sure, but 9 times out of 10, the negative is going to be the extraneous solution. And I still want you to list it, I just want you to tell me it's extraneous. Sometimes on textbooks, they'll just leave it off and then say the only answer is p equals 1. But I want to see both of them. Okay, the other one. The other one is going to be very similar, except you might notice now this says x plus 2. So we're going to have to square that. Just like the other one, except the way we square the left side is a little different now. The right side's easy. That's just 2x plus 3. Most people screw this up because they think the left side is x squared plus 4. But it's not. The left side is a FOIL question. The exponent means to write it twice. Now we don't have to do that to the radical part because we know that when you multiply a radical times a radical, it just cancels, especially when the radical matches. So if we FOIL this, we're going to end up with x squared plus 2x, and plus another 2x, and then plus 4. And this equals 2x plus 3. So just like before, if we've got all these x's, we want it equal to 0. So let me simplify it a little bit. X squared plus 4x plus 4 equals 2x plus 3. Now I want everything to the left so that it's equal to 0. So I subtract 2x. Subtract 2x from there. I'm going to subtract the 3. Subtract the 3 from there. So we have x squared minus 2x plus 1 equals 0. Hey guys, I told you about factoring. Factoring happens a lot in Algebra 2. So this is another chapter. We learned factoring back in Chapter 3. It happened in 3, it happened in 4, it happened in 5, and now it's going to happen in 6. 4 straight chapters where you have to factor. So this is a simple ABC. Yeah. Yes. Dang it, did I just come up with a bad problem? I think I did. 2x, subtract 2x, positive 2x. Oh no, this is a good problem still. Okay, so if we multiply the first with the last, we get positive 1. We make the list, it's 1 and 1. I have to make the 2. So it's plus 1 plus 1. So that means this is x plus 1 and x plus 1 equals 0. So we set each one equal to 0, and I don't actually have to solve it twice since they're the same problem. What am I doing? X plus 1 equals 0. But we already know the first one's going to be negative 1, so the second one's going to be negative 1. And then we go back and check. So here's the check. Something plus 2 equals the square root of 2 times something plus 3. So remember I said 9 times out of 10 the negative is extraneous? You have to be real careful with that because if you look at this problem, if I plug in negative 1 here, that's a positive 1. If I plug in negative 1 here, 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. And then it's inside the square root, so if you square root it, 1 still equals 1. So this one actually does work. So you have to check. Don't just assume that the negative is going to be the extraneous one. Although 9 times out of 10 it probably is. But there are special scenarios where it actually does work. And that's pretty much it. So remember when you square, or when you have radicals, try to isolate the radical. Don't mess with anything inside the radical at all. Get rid of all the numbers on the outside first. Try to add or subtract first. Try to divide second. And then square it. And then solve what's left. Once you get your answer, go back and plug it in just to make sure it's not an extraneous solution. So you guys have about 30 minutes to work on the assignment.